Hello students, welcome to our physics practical class. In this class, I am going to discuss about meter bridge experiment, construction and the working of meter bridge experiment. We will connect the components according to the circuit diagram. Now look at this circuit diagram. Actually, meter bridge is a practical form. Meter bridge is a practical form of Wheatstone's network. What is the meaning of Wheatstone's network? Wheatstone's network is an arrangement of four resistances in the form of quadrilateral used for measuring one unknown resistance in terms of three known resistances. So this is a meter bridge. A meter bridge consisting of three thick metallic strips. Three thick metallic strips. Those are arranged on a wooden board. What is this? A wooden board to form two gaps. Meter bridge consisting of three very thick metallic strips. Those are arranged where on a wooden board to form two gaps. This is the left gap. This one is the right gap of a meter bridge. So a uniform wire AC. AC is a uniform wire. A uniform wire AC of 1 meter length that is stretched and 1 meter scale that is fixed below the wire. Okay, a uniform wire AC of 1 meter length that is stretched and a meter scale is fixed below the wire. Okay, so why the thick metallic strips are used in a meter bridge for connections? So this point is very important. So actually the thick metallic strips are used, thick metal plates are used in a meter bridge for connections because thick metal plates do not contribute any resistance to the meter bridge wire. Thick metal plates do not contribute, thick metal plates do not contribute any resistance to the meter bridge wire. Actually, this is a meter bridge wire. Actually, this wire is made from manganese and manganese or constantan. Okay, why the meter bridge wire is made of manganese or constantan? Because manganese constantan having very high resistivity and very low temperature coefficient. Manganese constantan having very high resistivity and very low temperature coefficient. So that is why the bridge wire, meter bridge wire is made from manganese or constantan. Okay. So after that, a wire of unknown resistance. So what is this? A wire of unknown resistance. We have to calculate the resistance of this wire by using what? Meter bridge. A wire of unknown resistance that is connected across the left gap of a meter bridge. And a standard resistance box. What is this? A standard resistance box that is connected across the right gap of a meter bridge. After that, a cell and plug key is connected across A and C. A cell and plucky connected across A and C. What is the meaning of cell? A cell is a device which provides the necessary potential difference to maintain the continuous flow of current in the circuit. So what is the function of plucky? Plucky switches on or switches off, making or breaking the circuit. Actually, that is the function of the plucky. So a galvanometer and the sliding contact, that is also called metal slider or jockey, that is connected between points B and B. Okay, now actually the wire forms the two variable resistances. Those are P and Q. Actually, the jockey is connected to the point A. Galvanometer shows a momentary deflection in one side, and the jockey is connected to the point C. The galvanometer shows a momentary deflection in opposite side. Then the circuit connections are absolutely correct. There is no fault in the circuit. So actually the point B is called the null point. Point B, that is called null point, and AB is the balancing length. So what is a null point? That is very important. The position of the sliding contact on the meter bridge Y, at which galvanometer shows zero deflection. The position of the sliding contact on the meter bridge Y, at which galvanometer shows zero deflection, that is actually called null point, and so the length AB is called balancing length. It is the length of the meter bridge wire from the positive terminal, from positive terminal to the balancing point. Actually, this is positive terminal and this is the balancing point. So AB is the balancing length. So that is L. The remaining length BC is 100 minus L. Okay, so this is about the connection of a meter bridge. Meter bridge consisting of three thick metallic strips. Those are arranged on a wooden board to form two gaps. A wire of unknown resistance is connected across left gap. A standard resistance box is connected across right gap. A uniform wire AC of 1 meter length is stretched and a meter scale is fixed below the wire. A cell and plug is connected across A and C. Galvanometer and jockey is connected between D and B. D is the balancing point. AB is the balancing length. Okay. So what is the meaning of galvanometer? Galvanometer is a sensitive ammeter. It is a device used to measure a very small current accurately. It is a device used to measure a very small current, that is of order 10 power minus 6 ampere to 10 power minus 9 ampere. Okay, what is the principle behind the working of the galvanometer? That is also very important. A current carrying coil that is placed in the presence of uniform magnetic field, it will experience torque. A current carrying coil is placed in the presence of uniform magnetic field, it will experience torque. That is the principle behind the working of the galvanometer. Okay. So what is this? A meter bridge. It is having two gaps, left gap and the right gap. So connect an unknown resistance or wire in the left gap of the meter bridge. So what is this? Left gap. A wire of unknown resistance that is connected across the left gap of the meter bridge. Connect the negative terminal of the galvanometer to the point D. Actually, this is the point D, point D, and this is connected to the negative terminal. What is this? The negative terminal of the galvanometer. So after that, the positive terminal of the galvanometer that is connected to the jockey. Okay, so positive terminal of the galvanometer that is connected to jockey. So this is jockey, metal slider. So after that, connect the resistance box in the right gap of the meter bridge. Okay, so what is this? The right gap. This is the right gap. A standard resistance box. So this is a standard resistance box that is connected. Standard resistance box is connected across which gap? The right gap of a meter bridge. So that, so the point C of the meter bridge that is connected to one of the terminal of the plugging. So that is point C that is connected to one of the terminal of the plugging. And another terminal that is connected to the positive terminal of the battery. So this is another terminal of one-way plugging that is connected to the positive terminal of the battery, and finally the negative terminal of the battery that is connected to point A of the meter bridge. What is this? Negative terminal that is connected to point A of the meter bridge. Okay, so this is about the construction of the meter bridge. So after that, the jockey that is connected to point A. Galvanometer shows a momentary deflection in one side. After that, jockey is connected at point C. The galvanometer shows momentary deflection but in opposite direction. Jockey is connected to point A. What happens? Galvanometer shows one side full deflection. And the jockey is connected to point C. What happens? Galvanometer shows momentary deflection but in opposite side. And the circuit connections are absolutely correct. There is no fault in the circuit connection. Okay, thank you all of you.